Yes, so I'm Thomas. I made a terrible mistake. I didn't check the time properly. I thought it was in half an hour from now. Sorry for that. Right. So, how deep are your tests? Well, let's start with noticing that these are my opinions. If I provoked you, well, find me afterwards for discussion, because I want to learn from you. You have probably really good reasons why I provoked you. And yeah, it's interesting for me to learn from you as well. Let's start with the really basic question, and that is, why are we even interested in testing stuff? Well, we are interested in creating value, and we can't create value unless we can release our software. So therefore, we want to be able to create confidence so we can release whatever we're building. We are also interested in getting feedback from real users. And the question they can answer is, was this really what they wanted? Or did they want something else? Did we misunderstand something? So that's reasons for us to test, create value, and make sure that we get feedback. And remember, it is waste until they can use it. Until then, it has no value, the software we're building. So therefore, it's really important for us to release as often as possible and with something reasonable so we can get good feedback. Joe talked a little bit about this morning, that you want to release often and in quite small batches, and I totally agree on that. It's really important. So therefore, my definition of done is working software in production. Anything else is just uninteresting, to be honest. The documentation, yeah, it's fine if it's done, but no one can use our software unless it's in production and actually used by real users. So that's why I try to work using this definition of done, which may or may not provoke some people, and I hope it provokes some people, because provoking is good. Next question is obviously, who are we testing for? And the answer is not the QA department. The QA department, they are just some kind of proxy for real users. And if you test just for the QA department, it might end up like this. These guys, Volkswagen, they tested for the QA department. We haven't seen the end of this story. Me, I'm not impressed. So, most of us write software that will be used by ordinary persons, and therefore we want feedback from them. So these could be two examples. Someone using a mobile phone, there's lots of code in that one. A point of sale system, yeah, lots of code there as well. And also remember that quality is what the end user experiences, nothing else. Perhaps something else. So how do we do this then? Well, there are lots of different ways. But end-to-end, from the user interface, is very common. And that's where most companies or organizations start, if they don't have any proper test automation. It happens that you test it from some kind of endpoint, if you have a web service or similar. Then there's integrated tests. And integrated, in this case, means stuff that is, I don't know, many objects. This is internal in our monolith. So I'm not talking about anything else. I'm not talking about testing towards a database, testing towards an external web service or something. But integrated tests are something that some people do. And then unit testing. And unit testing should be boring behavior with few, if possible, just one object involved. This is not always possible, and yeah, that could be an issue, but this is a few different ways of testing. An end-to-end test, well, that's pretty much similar as test driving a car. You have to assemble the entire car, fire it up, and actually run it before you can test it end to end. But you can test parts of the car as in an integrated test, if you want. You can test the power plant. That's totally possible. But it won't tell you anything about the handling of the car, for example. It will tell you a lot of things, such as how much torque can you get from the engine. Unit tests, that would be the equivalent of testing the internal parts of an engine. So how many in here has rebuilt an engine? 1, 2, 3. Okay, 4. So most of you haven't, but yeah, it's really important that you're really careful, and it's really important that you make sure that all pieces have the correct properties, such as this piston rod. It's really important the size of the larger hole there. If it's too small, the engine won't even turn around. If it's too large, it will break down. So the tolerances here are really, really small. How many in here has heard about something called the testing pyramid? Okay, some of you, not all of you. Interesting. I thought that was common knowledge today, but it is obviously not. So this triangle represents a pyramid. What do we mean by this one? Well, this is a way for me to organize tests and at the same time try to tell you how many you should have of each of them. So at the top, we have end-to-end. The pyramid is quite narrow there, so this means they should have really few end-to-end tests. Somewhere in the middle, a few more integrated tests. But what we're really interested in is lots of unit tests. But when should you use what of end-to-end, integrated, and unit tests? Well, it obviously depends. These are 3 criteria that are really good to think about: diagnosis, speed, and confidence. Diagnosis will tell you if something's broken, what was broken. Speed, it's boring to wait a long time for test to finish. So therefore, you need a really short feedback cycle. And you also need confidence. Is this something that will verify the system so I can put it in front of a user? Will I be embarrassed or not? And if it has bad quality, doesn't work as it should do, then at least I would be embarrassed. And I hope you would be as well. So we're really trying to do something really good because our users are worth it. An end-to-end test has a few properties that some of them are good, some of them bad. Slow, that's not a good property. It's very common that end-to-end tests are done by someone else, another company, another department, another person, a specific tester, for example. This gives you slow feedback as well. They tend to be risk-based. That is, we can't test everything, so therefore we just test the things that we expect to break. Quite simple. An end-to-end test will verify that everything is properly connected. So if you have a system that consists of many small pieces, we are able to verify that the wiring actually works properly. It has many execution paths. There's lots of ways through a system, which is a problem for us if we want to test it thoroughly. They tend to have quite bad diagnosis precision. We don't really know what was broken when an end-to-end test fails. We know it's broken. That's a good start. But was it the file system that was filled? Was it, I don't know, HTTP port that wasn't available? Or was it something else? I don't know. There's a lot of different possibilities here. And the wider the scope, that is, are you testing, say, complete business process for some reason, which you probably will have to do somewhere, the test will be more fragile. Lots of things can go wrong. And as we know it, if things can go wrong, they will. We just don't know where. End-to-end. What do we mean by end-to-end? It turns out that developers and testers, we have different definitions of end-to-end tests, which came as a surprise to me when I learned it. As a developer, I'm happy if we can go from the UI or whatever we have to the database one way. That's enough for me. I know that I've probably touched most part of the system. A tester, on the other hand, would probably think about some kind of business process. You create, say that you create a user, you create some kind of product, you make sure that you purchase that product, you accept some payment, create a receipt, so forth. That's an end-to-end test for a tester. So when we talk about end-to-end, we actually tend to mean different things depending on our background, which could be good to know. And therefore, since we mean different things, we can also talk about width, not just depth, but also how wide our stuff. So how many layers will we pass? That could be depth. But how wide are the tests? That's another property that could be interesting. And we want to make sure that we fill this surface in a good way. And we can do it in different ways. But we want to make sure that the business processes are covered properly, as well as we hit all the different layers in the system. So testing width, that's probably the topic for another presentation, but not today. So what I'm talking about is pretty much this. This would be depth. We are using a system from some kind of browser, and we're hitting lots of different components. And each of these components could be faulty. Therefore, we would have something that verified that everything was connected, but we wouldn't know if something was broken. We wouldn't necessarily know it easy what was broken. So this gives us low diagnosis precision. It's unfortunately slow. Firing up a browser using Selenium is obviously a lot faster than having a human person doing it, but it's still slow. It takes a lot of seconds. It will, however, maybe create some confidence. We know that the most important business process is possible to do, which obviously is important. I think it's about 10 years ago, I made a mistake. I made a mistake that disabled the possibility to purchase things from Sony Ericsson's website. It was down for 2 days. That was very unfortunate. No one had tested that it still was possible to do a purchase, so all of a sudden we didn't accept credit cards. So in that case, it would have been nice if someone had done a test from end to end, verifying that the most important business flow actually worked. It didn't. We fixed it in 2 days, and yeah, no one told me that they were angry afterwards. At least that's good. But we need to create confidence that we can release stuff, and we can do that through an end-to-end test. But they have bad focus. They test everything, and therefore it's very hard to understand what's wrong. And focus, that leaves me to something called depth of field. Do we have any photographers in the audience? No photographers at all? Okay, that's unusual. We usually have 1 or 2. The definition of depth of field is the amount of distance between the nearest and furthest object that appears acceptably sharp in acceptably sharp focus in a photograph. That's very vague, so it's obviously subjective what you think is okay. But this could be an example. We can see that the closest number 8 ball here, the number 8 ball is quite close. It's quite focused. In the far end, I can see something that's green. I don't even know which number it is. I don't play pool. But we want to focus on one thing, if possible, because that's a lot easier for us to verify that it actually works. So pretty much like this, let's focus on this thing, the price calculator. That's what we actually are talking about when we aim for something called, well, shallow tests or, yeah, something like that. I introduced you to the testing pyramid a few minutes ago. Of course, I had to come up with something new, and therefore I invented the testing cone, which is pretty much the same thing, repeating the properties, that it's slow. But depending from which direction you watch, you see this cone, it has different properties, where fragility and low precision is perhaps, yeah, they're main problems. Slow as well, of course. But this is something that the business is interested in, so we have to do some of it. If you go down here, we have more technical tests. The integrated parts, integrated tests here are quite unclear. They have quite unclear precision because we're testing a lot of things at the same time. So what we really would want to do is have something with high precision, that are really fast, and are really stable. That would be the best option that we have. So this is what I want us to focus on. Something that is high precision, fast, and therefore very stable. A lot of people are wondering at this point, because they didn't understand when I said integrated earlier. Do I mean integration or do I mean integrated? Two words, very similar. So let's just make it clear once more that integrated as in a large chunk functionality at the same time within our monolith probably. And therefore not integration. I'm not talking about communicating with the web service or whatever somewhere else. We need to verify that as well, but I'm going to ignore that today. So that's another topic which someone else will talk about some other time. So integrated. What is the problem then, if we test too many things? Well, if we have, say, 3 different objects like this, they have branching points inside of them. So there are 3 ways through the first object, there are 8 ways through the second object, and there's 5 ways through the last object. And if we only test from the blue arrow, how many tests do I have to write to be able to verify each of these possibilities? Did I hear a number here? About 100. 5 times, so let's say 3 times 8, that's 24, times 5, that's actually a bit more than 100. That's 120. Would you write 120 tests to verify this? Maybe, maybe not. I would probably not do that, because 120 is a lot. And suppose that someone pushes another object into this equation. All of a sudden, we will have to test 3 times 8 times 5 times 13 combinations. And that's approximately, or actually exactly 1,560 combinations. So this is not possible. This is too many. So what is the problem then? Well, the problem is this graph. It rises very, very fast. And this is the case if we try to test too many things at the same time, or something from the edge of the system. Occam's razor. Anyone heard of that? Nope? Yeah, a few. I saw it on the BBC show not too long ago and thought it was a great quote, so therefore I would wanted to include it here. It says, among competing hypotheses, the one with the fewest assumptions should be selected. So this is really important within science, but it's also very important within testing. We don't want to have a lot of assumptions. We want to have few assumptions, because that's good. And this is a quote from someone who lived a long time ago, William of Ockham. I don't know where. I didn't check that. But I understand that he lived like 800 years ago, something. So my interpretation of this is we want few assumptions because that gives us less risk. That's good. And this leads me to something that has very few assumptions. Unit tests. The definition of unit testing that Roy Oshero offers us is an automated piece of code that invokes a unit of work in a system and then checks a single assumption about the behavior of that unit of work. A single assumption. That's few. That's just one assumption. That's good. So, test a small part. Only one reason to fail. That's good. That gives us high precision. When it fails, we know that there's only one thing that should make this test fail. Good unit tests tend to be possible to execute in parallel. So therefore, we can have lots of them. And they are really fast. Some seconds. That is, I can run thousands of unit tests a second, which is really good. And, well, I say that this is a well-known minefield because a lot of people have different opinions. And that's okay. Find me afterwards and let's have a chat about it. At the same time, there are some things that a unit test doesn't do, which is really good as well. Have more than one reason to fail, obviously. They don't offer slow feedback. They don't require exclusive execution. They don't use a network, that's slow. They don't use the file system, and they don't talk to database. And this is some properties that Michael Feathers offers us, and well, parts of this could be discussed. File system, if we have a really fast file system, is that a problem or not? I don't know. I wouldn't be too dogmatic about that. Sometimes it's good to actually verify that the file system behaves. Perhaps not verify that the file system behaves, but to verify that you use it properly. But it is slow. So this gives us this situation. We have lots of pieces. They work perfectly, but they're not connected. Bummer. So what can we do about that? Well, if we see our system as lots of small pieces that have some kind of conversation, then we can actually start thinking about how we should solve this. So it's interesting to have, you have some kind of consumer, some kind of provider, almost always. That is, an object is using another object for some reason. And the consumer is interested, can I ask a particular question? The provider is obviously interested in, am I able to understand the question? Because if I can't understand it, I definitely can't answer it. It's also interesting to see, do I get the expected answers back, or do I get something else? And the provider is obviously interested in, am I able to answer the questions, not just understand them, but also answer them? So this leads to that we can verify interaction. Quite simple, using mocks. How many in here are using mocks? Lots of people. JMock, anyone? No, okay, we're in Poland. I would expect to use Mockito. And I do that myself. But mocks are very nice because they can force us just to define the expected methods and verify that we don't call them too many times, for example, perhaps just once. Mocks have a friend that is sometimes called stubs or fake objects, and it's kind of sad that there's no difference between these two in Mockito. You can't really say that, or actually you create a mock and then you say that if you get this question, answer with this response, which is the definition of a stub. So it's not clear in Mockito which is what, always. But we can make sure that we stub things, and that can lead us to implement methods correct, if you do it properly. So we have some kind of interaction that will lead to test action shortly. Some answer that later on will lead to an assertion. I thought that was abstract. Maybe not you, but I did. And therefore, an example, we're at the developer conference, so talk is cheap. Is there any code behind this? Yes, there is. But before we can look at some code, we need something to think about. So this is a very high view of a tax agency system. And I have verified this with a friend of mine who worked as a tester at the tax agency. Let's zoom in on just a small piece of this. If you have a business, there are some rules that you have to follow, such as you have to take care of the VAT properly. You have to make sure that the government or the tax agency get the proper reports at the proper time. So this is an example of a test that will verify that something has been implemented. So let's zoom in on this one a little bit. I'm interested in making sure that the VAT rule engine is used at all in this case. So therefore I create a mock from it. I create a new business and I feed it the mock and verify that and verify then that it's called when we ask for the VAT due date. That is the date when I was supposed to when we were supposed to send in the report to tax agency. And in this case, I will create it with any string at all, and I will also verify it with any string, because which string, or in this case, the new business, any string there, that would be the company registration number, and it's not really interesting in this case which registration number we are using. That's something for later. But this forces me to implement the method get VAT due date. It won't work otherwise. Next step is to make sure that we have some kind of stub that actually returns the expected values. Zooming in a little bit here. I'm expecting that a date should be returned, and that date is the date when you had to submit the report if you did business within the EU. That is 28th of February. And so therefore, I'm creating a stub that will make sure that if it gets a specific string, in this case, 5569215576, which is the company registration number of my company, then return the actual date. Create a new business with that registration number and this rule engine, and then make sure that the stub actually returns the proper value. This verifies that the stub values are used properly, and also that the VAT due date is not just called, but also properly implemented. Next step is to implement, in this case, the provider, the VAT rule engine, properly. And here's the trick. We are now trying to implement the VAT rule engine and we're not mocking anything, we're not stubbing anything, but we are using, or I am using, the exact same values as I did for the stub. So in this particular case, when I feed it the same component registration number, it should return the same value as the stub just did. This is very important. Because this forces me, or sorry, not force, but this allows me to know that the stub and the actual implementation behaves exactly the same way. You don't have a situation where you stubbed something and then you implemented the collaborator and you didn't test that particular case. So you didn't know if the stub did actually agree with the actual implementation. But if you do it like this, so you stub out some values and then you use the exact same values later on when you implement the collaborator, then I claim that you will be able to cope with unit tests much more than a lot of people think. So the same argument that stub received got to have to return the same value. Okay, and I'm not sure about the last sentence here. I changed it early today, but I'm not sure. So, recapping a little bit, we have some kind of interaction that leads later to a test action. We have an answer that later on will lead to an assertion. And if we do this, then we can use unit tests a lot more than a lot of people think. And we don't have to resort to heavy integrated tests. And therefore, we don't have to test everything from the outside. So an interaction leads to a test action, an answer leads to an assertion. And this is pretty much like bookkeeping, where every transaction has to balance. And I think it's called double Italian bookkeeping, where the sum should be 0 for each transaction. And it's not a new invention, that's something that they came up with in the 14th century or something like that. So it's not the mafia in Italy who came up with this concept. If you think this was abstract and want to look at it again, there's a blog post that I wrote not too long ago where I describe this again. So are unit tests good enough then? Well, we know that they have good diagnosis, they tend to be fast. Are they able to help us create confidence? Yes, they are at least very precise. If they're properly implemented, they will be fast. And if the actual implementation acts as the fake, that is, the stubbed collaborator, then I'd say that this gives me confidence, speed part gives me confidence, and finally, the confidence gives me confidence. You can't say that. But yeah, I'm actually happy with unit tests in this situation. It works pretty well. What happened with the path of execution then? Well, we're able to break the multiplication here. So instead of having to test 3 times 8 combinations, we have to test 3 plus 8 combinations. That's a lot better. 3 times 8 is 24. This is 11. That's half. And we don't have to take into consideration whatever happened between after the second object. Therefore, we are able to reduce the number of paths of execution that we have to verify, which is great. And I don't think 11 is enough. It's probably a few more. But yeah, you get the idea. So we had a problem with this graph rising very, very fast. And the solution is to make sure that we stub out values and then use the same values when we implement the proper collaborator, the collaborators properly.
And what if you want to refactor your code a little bit, like change the design, introduce like a few another objects, something like that?
Yeah.
Isn't that the way you just propose us? Make your design like coupled or something like that?
Yeah, the design would be coupled, but it would be less coupled than compared if you tested everything from the outside, because then you would have to change hundreds of tests instead of a few tests. But yes, things are somewhat tightly coupled. But if we want to be able to use our system, stuff will be coupled. It's just a matter of how hard it will be to change them. And I claim that this is easier than compared to you test everything from the outside. But it's not necessarily easy. Refactoring isn't necessarily easy. The way to do this, at least in my book, is to use something called outside-in development. That is, you write a failing acceptance test and then a smaller unit test. So the way to do this is write something from the outside that actually verifies that you can accept this. Then an inner loop where you write unit tests, perhaps many of them, and then make them pass, and before you're done, you refactor. You don't skip the refactoring part. This is something described in this book that I don't know if you've read or not, but if you haven't, this is among the best books that you can read. Growing Object-Oriented Software Guided by Tests by Nat Price and Steve Freeman. It's a fantastically good book. And it happens to be the case that this is the same way I would implement stuff if I used BDD, as in behavior-driven development, which is not the topic today, but if you're interested, I can talk about that later on. But this takes so long time. We will never be finished. Or maybe we will. But the thing is that you have lots of time to write the tests properly. I don't know if you're familiar with XKCD, but this is a table that shows you how much time you actually have. And it's not even correct. You have more time than this. But suppose that you have a system that lives for 5 years. That's reasonable. Suppose you do something 50 times a day. That thing takes 5 minutes. Then you have 9 months, according to the lower left-hand box. You have 9 months to automate this. So you have plenty of time. Don't tell me that you don't have time, because you have. And if your manager says you don't have time, well, change manager then. That's possible. Or don't ask. Just do it. And I want you to always ask yourself, when you implement something, how can this be tested? And if it can't be tested, can you use it? Sometimes you can, sometimes you can't. But if it can be tested, can you test it with a unit test or not? The answer is yes, much more often than some people think. But if you can't, well, you have some kind of problem. What is that problem? Do you have something strange with your design, perhaps? I don't know. But you have some kind of problem preventing you from using unit tests. So let's recap very short. You want to have few tests that have low precision, are slow, are fragile. You want to have lots of tests that has high precision, are fast, and very stable. My conclusion here is that you need a few deep tests to verify that stuff like, does it even start? That's a really important question. If you can't start your system, you can't use it. No one can use it. Is it properly wired? It happens that people forget to do stuff. So that's important. But you want much more shallow tests than deep tests. Because they have good diagnosis, they are fast, and they can create confidence that you can release. And they tend to be small, which can force you to simplify collaboration and stuff. And remember, crashing hard, it's never a problem if the altitude is low enough. Falling off from a chair is not a big problem. From a ladder could be a larger problem. Some guys that has helped me with this presentation. My good friend Johan, Peter Koffler from Vienna, and Oslak Helsey, father of the Cucumber, and some guys at something called Software Development Gang when we had a meetup in Berlin last year. So I'm Thomas, and I've been talking about how deep are your tests. Thank you for listening.